Welcome to the DIY Honda Garage channel. The DTC P1077 indicates that the Intake Manifold Tuning IMT valve is stuck in the high RPM position. In Honda's V6 engines, the IMT valve plays a crucial role in optimizing performance across various RPM ranges by adjusting air intake to the engine manifold. This ensures that the engine operates efficiently, maintaining balance between power and fuel economy. When the IMT valve is malfunctioning, it can lead to poor engine performance, increased emissions, and reduced fuel efficiency. The IMT actuator, which is responsible for controlling this valve, is located near the intake manifold. It receives signals from the engine control module, ECM, to open or close the valve based on engine requirements. Proper functionality of these components is critical for the car's overall performance and efficiency. The DTC P1077 results from the IMT valve being stuck in the high RPM position. The IMT valve is an essential component located within the intake manifold of Honda's V6 engine. Its role is to optimize air intake dynamically, responding to various engine speeds to enhance performance and fuel economy. The IMT actuator relays electrical signals from the ECM to the valve to adjust its position as needed. If the actuator fails or there are electrical issues, the valve may remain stuck, impacting engine performance. The actuator itself is typically found near the intake manifold and is connected to the ECM via wiring harnesses. Understanding the context of how this valve operates helps in diagnosing associated issues. Several possibilities could trigger DTC P1077. First, the IMT actuator may be faulty or failed, preventing it from controlling the valve properly. Second, poor electrical connections to the actuator or the ECM can lead to erroneous signals, resulting in activating the DTC. Third, if the ECM, which acts as the vehicle's brain, is defective, it may not send appropriate commands to the actuator. Lastly, wiring issues such as shorts, breaks, or corrosion can interrupt the signal flow between the actuator and the ECM, leading to improper operations. Identifying these potential causes is vital for effective troubleshooting and resolution. Drivers may experience several symptoms when DTC P1077 is active. A notable symptom is reduced engine performance due to the IMT valve being stuck, which may lead to inadequate air intake and thus affect power output. Drivers might also encounter engine stalling, especially in lower RPM ranges, as the system struggles to adapt to engine demands. Increases in emissions may occur, as improper air-fuel mixtures can lead to incomplete combustion. Furthermore, the check engine light will likely illuminate on the dashboard, indicating that there's an error that requires attention. Recognizing these symptoms can help in addressing the issue before it leads to more severe problems. The first troubleshooting step involves turning the ignition switch to the on I2 position. Make sure to record all freeze frame data and any onboard snapshots prior to beginning the troubleshooting process. This information could provide valuable insights into what conditions triggered the DTC. Next, clear the DTC using the Honda Diagnostics System, HDS, which is essential for resetting the vehicle's onboard diagnostic system. By doing this, you can accurately establish whether the issue is persistent or may have been an intermittent error. This step is crucial in starting the troubleshooting process on a clean slate. In this step, perform the IMT test through the inspection menu on the HDS. This diagnostic test assesses the operational status of the IMT actuator and valve. If the test results are satisfactory, indicating that the system appears to be functioning correctly, it could suggest that the DTC was triggered by an intermittent failure. In this case, you should check for any poor connections or loose terminals connecting the IMT actuator to the ECM. On the other hand, If the test results are not okay, proceed to the next troubleshooting step. Clear documentation of results is vital for future reference. Begin this step by turning the ignition switch to the lock 0 position before disconnecting the IMT actuator's 5P connector. Once the connector is disconnected, turn the ignition switch back to the on 2 position. This sequence ensures safety when working with electrical components, preventing any accidental shorts or damage. With the IMT actuator disconnected, you will be able to proceed to measure the voltage supplied to the actuator in order to check if the system is delivering the appropriate electrical power. Proper voltage is crucial for component operation, so this measurement will guide further troubleshooting. In this step, you will measure the voltage between the IMT actuator's 5P connector, terminal number 1, and the body ground. Ideally, the voltage reading should be around 5 volts, which indicates that the actuator is receiving sufficient power. If the voltage measures close to 5 volts, it suggests that the electrics supplying the actuator are functioning correctly, allowing you to move on to further steps in the diagnostic flow. In contrast, if the voltage reading is significantly different, it implies that there may be an issue with power delivery to the actuator. This step is crucial for validating whether the actuator receives the power needed to operate correctly. If the voltage is not around 5 volts, the next step is to turn the ignition switch to the lock 0 position for safety. Following this, use the HDS to jump the SCS line, which allows you to access the system's diagnostic capabilities without interference. After this, disconnect the ECM connector C, specifically the 49P connector. The purpose of this step is to ensure that no interference occurs during the continuity check between the IMT actuator and the ECM. Properly isolating components is crucial to accurately diagnose where the fault might lie in the electrical system. The final step of this troubleshooting process involves checking for continuity between the IMT actuator's 5P connector terminal number 1 and the ECM connector terminal C11. This is done to verify that there is a proper electrical pathway, allowing signals to transfer between the actuator and the ECM. The use of a multimeter will help establish whether there is continuity, which indicates that the circuit is intact, providing a reliable path for communication. If continuity is present, it suggests that both components are operational and the issue might reside elsewhere. Conversely, a lack of continuity indicates an electrical fault, which could stem from damaged wires, poor connections, or a faulty ECM. After completing all troubleshooting steps, it's essential to verify that the repairs performed have restored proper operation of the IMT system. Begin this verification process by ensuring that all components are reconnected correctly and functioning as intended. Clear the DTC using the Honda Diagnostic System HDS once more to reset the onboard diagnostic system. Following this, conduct a test drive to evaluate the vehicle's performance. Observe whether the check engine light remains off and check for any symptoms related to the original DTC. Final verification is crucial to confirm the effectiveness of the troubleshooting and any parts replacements performed. Preventive maintenance is key in avoiding recurring issues related to DTC P1077. Perform regular checks of the IMT actuator and valve system, ensuring that they function efficiently. Inspect all electrical connectors leading to the IMT actuator and the ECM to ensure no corrosion or damage is present. Additionally, monitor for any engine performance symptoms regularly and attend to repairs in a timely manner before they escalate into larger issues. Establishing a preventive maintenance schedule tailored to the vehicle's needs will significantly enhance the reliability of the air intake system and the engine's overall performance. In summary, DTC P1077 indicates that the IMT valve is stuck in the high RPM position, which can significantly impact vehicle performance. Understanding the components and their roles is vital for proper diagnosis and repair. Following the outlined troubleshooting steps meticulously will help identify the root causes of this issue. After addressing the problem, incorporating preventive maintenance measures into your vehicle care routine will contribute to the longevity and reliability of the engine's performance. Awareness and proactive measures can ensure that your Honda Accord continues to operate efficiently and effectively. Please like and subscribe to the channel. See you next time.